Okay, next up we have Daryl DeRosia and Colleen Simanek from Comcast, and they're going to be talking about creating a true carrier-grade Wi-Fi experience. I think we're all excited to hear about what that is.
We are too.
So this is your slide advances. Yeah, are you just using this for notes?
Yeah. Okay. Thank you, everybody. So, as you stated, I'm Daryl DeRosia. I'm actually a consultant for Comcast. I work for a company called NextGen. And Colleen here has been with Comcast for a little while. So, got a pretty wide background with Wi-Fi deployments and done a few events, Super Bowl and World Series, things like that. And Americana for the World Cup, you know. So, trying to make Wi-Fi work where it isn't supposed to is sometimes a challenge. So, to get to a carrier-grade experience, you know, first you have to kind of understand what does carrier-grade mean, and there really isn't a true success metric or SLA or SLO that's really out there. It's a subjective measure still. And there's some organizations that are trying to provide that, but there are certain things that you have to provide, and that's you have to have a large footprint, and you have to also understand that Wi-Fi is not cellular. It wasn't ever intended to be cellular, and we're trying to make it more like cellular and provide an experience that's consistent no matter where you go, so that the experience is enjoyable and seamless to the end user. So you also need to have good speeds. You need to have a secure system, reliability in there, and it needs to be easy to use. So trying to achieve all of those things at the same time is sometimes difficult. And the Wi-Fi technology has some limits that the FCC has put in place, that you have to play nice with other networks. There's a lot going around right now on the internet. Marriott, I think, just got fined by the FCC for shutting down other people's Wi-Fi networks in their space. So you have to play with whatever networks are in your area, and you can't shut somebody else down. So. First thing we'll talk about is the large footprint and how to get there. So people need Wi-Fi where they are. And how do you know where they're going to be? Well, you know, you can throw out a lot of access points and try to figure it out, or you can do traffic studies and things of that nature. So the Comcast approach and what makes sense is to kind of have different verticals of coverage. So first we've got an outdoor network. We've also got a small medium business network. We've got residentials. We've got high profile venues, and we've also got roaming agreements in place. So all of these networks have different challenges as far as deployment. Outdoor, you have to compete with the businesses that are there. Starbucks isn't going to quit broadcasting their Wi-Fi because you want to broadcast yours outside their store. And likewise, in the small medium business, you have networks that are next door to your store. In this hotel, for example, if you were to boot up a scanner in your room, you'd probably see 20 networks that are from outside of this hotel at some level of interference that are taking away from the ability to provide a great experience. So, you know, every venue has a unique challenge associated with it, and the users are also different. Outdoor, typically you see a lot less laptops. People don't tend to sit on the street with their laptop. A lot of people in this room probably do. But most people, it's a smartphone or an iPad. It's just for a minute. It's just check email. Whereas at a coffee shop, you sit there because they have a power port, right? You're plugging in your laptop and you're downloading a lot of information. So.
Thanks. So as we're discussing coverage, it seems appropriate that we should at least first talk about what kind of equipment that we put out there. Outdoor, we have both on the Strand and in the Vault. And the Vault option is for the cities that have their infrastructure underground. All are using the DOCSIS 3.0, and they're dual band 2.4 and 5 gigahertz support. You know, we have AC models that are on the roadmap. While AC has all the buzz, it's a good time to remind everybody that that's 5 gigahertz only, and I think there was a reminder earlier today that 2.4 is unusable anyway, so it works out, I guess. But anyway, but there are wider channels and more modulation, so the speed and the throughput should be higher in theory. But I think everybody in this room, the more interesting factor that we really have to deal with is all the legacy equipment, right? So how many different AP vendors? Can I get a show of hands? I'm going to make you guys do exercise like all afternoon, so I'm going to get some stretching and some hands to see who's awake here. So how many people are dealing with multi-vendor AP environments in their infrastructure? All right, a few. Okay, and multiple code versions even with the same vendor? Anybody? Okay, all right, so you get basically what we're talking about here. So, all right. As Daryl mentioned, our deployment approach, there's many different verticals, and I wanted to take a minute just to show a quick picture of how this starts to fill in coverage for the users to get that large footprint. So I just also want everybody to keep in mind that if you went to the Xfinity Wi-Fi app and looked, you would see more the dots would be a little blurrier, and that's to protect people's privacy because we don't want anybody knowing exactly what the locations are out there. But I think the interesting piece here is really where to put the APs. Right? So most of the time, you might not get much control over the AP placement, I mean, it's just what you can do. Your infrastructure is in certain places or something like that. But if we can consider where to add the APs, you never go wrong with putting APs where the users are, right? I mean, there used to be models where you have a convenience access, I'm putting a new building up, and let's just put Wi-Fi there, and, you don't even know what the building materials are. You don't know, most of the time they don't have walls in place. They're like, oh, we can run our conduit right now, because the walls are open, which, don't get me wrong, makes sense, but yet from an RF standpoint, you really don't really know what you're going to be dealing with when the building is finished and you now have to light up APs and say, yeah, okay, Wi-Fi is just going to work there. So, users want and expect good coverage, and they should definitely get it. So as we basically blow this up and aggregate it a little bit more, this rolls out, starts to show that large footprint and overall coverage. And one of the things that when we talk about coverage, I usually look at two separate reports when I'm dealing with, do I put the coverage in the right place, and is it actually getting utilized and making sense? And that's usually a top-end most utilized AP report and a bottom-end least utilized AP report with both respect to associations and bandwidth, and both give you very valuable information. So if there are sites that aren't being, or that are being overutilized, maybe you put more APs there. I mean, don't get me wrong, it's, you're going to need time and money and resources to do so, but, at least if you can identify the areas and have those metrics, it's something that's valuable, right? And then the other part, where it's the least utilized APs, that's something that I think is very valuable because that helps you identify your radio problems, your misconfigurations. Maybe that AP is just not used there, and maybe you should basically remove that and try to put that somewhere else. Again, another money, time, resource problem, but something that you need to consider when you're looking and you're growing your footprint. So if you're going to build a network, that there should be enough areas for the users to access the network, and they should be able to reliably access the network, which basically comes to our next point of view, which is good bandwidth and speeds.
So bandwidth and speeds are somewhat subjective a lot of times, right? What does the user expect? Well, they expect fast. What does that mean? Does anybody have a written definition anywhere? I think the FCC and some other people have kind of suggested what broadband is, right? And you can kind of go off of that. But the fact is that people want what they have at home or an equivalent, right? And they want it pretty much wherever they go. So access points aren't created equally, and there's a lot of differences. And I put up an actual test report from an access point kind of randomly. I'm not even sure which particular one this is. But we do a lot of testing, and some access points are really great on their bandwidth throughput numbers if you use all large packets. I'm in a room of network engineers. You guys know what packet sizes are on your networks, right? Are they all big? I got a few laughs. I'm thinking not. So what we see is there's a difference in packets. Not all packets are created equally. And the access point's ability to process packets are also differently. So we test access points in our lab to see what we can actually get out of that in different environments. So we take an access point and we run it through a test harness where we can create as much of a real-world environment as we can. We simulate noise, we simulate Bluetooth, and we also do this in a clean environment. And we also do packet distributions, because when the real traffic's out there, you have some 64-byte packets, and you've got some larger packets as well. So you have to make sure that that you're able to process the traffic that's coming at you in the different locations.
Security. So as, whoops, this one. I would be remiss if I didn't have some type of picture on security up. So here we go. This is courtesy of the folks at Cable Labs. This is basically a sample of a soft GRE architecture and an overview. So the point here that I want everyone in this room to know is that there is a complete separation between the public and the private Wi-Fi. So the public Wi-Fi goes through to a wireless access gateway, and that's where you get all of your settings, and it's tunneled on a layer 2, and on your private, you're basically NATA straight out to the internet. So for two stations to communicate to each other in the same AP, you'd have to go out to the internet and come back. So that's something to note. This also shows that there is a captive portal, which means that it's an open SSID, and that we're using web redirects for that. So this is where I'm starting with security, so we could only get better at this point in time. So a lot of you guys run 802.1x networks, and you've been doing that for a while. One of the things that we're trying to do is that we're getting an 802.1x trial for our public Wi-Fi right now, so that's been pretty exciting. The technology's been around for a while, and most of you guys have been supporting it. So just for those who aren't that familiar with it, real quick, 802.1x is the user will authenticate first, meaning that the supplicant will initiate an auth request with an EAP start message to an access point. Then that will go to the authentication server, and there will be a 4-way handshake that takes place, right? Upon successful authentication, the client will associate to the SSID in an encrypted fashion and get a DHCP address and be able to use the network in a secure fashion. It's great, right? So I wish it was that easy, and it's super easy to troubleshoot, and that overhead of the security is no problem, but you know, ideally, you do want to set up your secure channel, so it is worth that extra overhead in my belief. Some of the other things that are getting buzz is this idea of like federated access, to tie that into there. I'm sure many of you are familiar with the EduRoom network that's out there, and I just wanted to make sure that the idea that a user will attempt to authenticate, and the authentication server that AP is being configured with may farm that authentication request off to another, authentication server that's in their federation by looking at the realm of the authentication request. So, if you're not part of my infrastructure, that's okay. I may have a relationship with someone who can vouch for you. You're still going to get authenticated. You are who you say you are. And the other thing to note is that the user credentials for the local authentication server are never basically being used. It's a very good method for the traditional guest access network that's in place. Taking that a step further, there's also this idea of Hotspot 2.0 or Passpoint. This is an initiative that was in conjunction with IEEE, the 811U spec, and also with the Wi-Fi Alliance. So all the magic here happens upon network selection. So instead of choosing a wireless network or SSID, there are now some additional elements available in the beacon. Currently, pre-Hotspot 2.0, the only thing you would see in a beacon would be SSID and basic security. So the IEEE 802.11u protocol enables a mobile device to have a dialogue with a wireless AP that's pre-association to determine what capabilities that network can support. So the two protocols that 11u uses are the generic advertisement service, the GASP, and the access network query protocol, the ANQP. So when a user with a Hotspot 2.0 mobile device comes into range with a Hotspot 2.0 capable device, it will automatically open up a dialog to determine if the AP has the capabilities. So this is being done using ANQP packets advertised by the Layer 2 GAS service. So this is all pre-association. So at this point, I'm basically asking you a few questions to see if you're local to my network and you're on my domain, authentication happens, everything's all good. Or not good, depending, it's authentication, right? So you get authenticated and then you start using the service. For somebody who's not in my domain, then I basically start asking a few questions. Are you part of any of the domains that we support? If so, then I farm that request off and we can kind of go from there. So this all happens, and then afterwards you do your normal 802.1x authentication, and it's business as usual on the network. So some of the EAP methods that Hotspot 2.0 uses is EAP AKA, EAP SIM, TLS, and TTLS. So It's pretty good, and it's something that I'm hoping will catch on more and more. Of course, it really needs the client support, but luckily, since people are refreshing their client devices more and more frequently, hopefully we'll get there a little bit quicker. But this is something that we're working on, and we're going to be in trials to be doing in the next few months. So this is pretty exciting for getting the security piece of it done.
So reliability is the next thing, and Wi-Fi wasn't really created with reliability in mind. It was originally created to get that Ethernet cable that you couldn't run through a wall, right? It wasn't created to have 500 people, 600 people in a room and connect simultaneous. So there's a lot of things to overcome in creating that Wi-Fi. As we heard earlier during Burning Man, 2.4 is dead. It's completely out, right? And there's a lot of other locations where it's impossible to use it as well, or very close to it. And there's still devices, though, like the iPhone 4S, that are very popular devices that only support 2.4. So at this point in time, you still need to have some presence on 2.4. And even in stadiums, it's about a 40-60 split in 2.4 only versus 5 gig devices. So you do have to support those devices. And the way the radios work are they're not willing to talk when somebody else is using the frequency. And that's kind of a requirement. So there's rules around that, and one device at a time has that talk stick. So you have to manage that in conjunction with the spectrum. Now, how do you do that in an environment that looks like this from the spectrum analysis? This particular environment was New York, Times Square, about 2 years ago, maybe. And over on the top left over here is the 2.4 band. Now, if it was blue, that would be usable. That's pretty much all green or yellow, and something is always talking. This was 2 years ago, and a lot less smartphones were out there and tablets. So what that ends up doing is these dense urban environments have a lot of noise. They're more like a war zone than anything else. And how do you accommodate for this? Well, in some instances, you need to turn your power down. In others, you need to add APs. In others, there's no choice. If you want to have a reliable service, you need to turn off 2.4, is what they did at Burning Man. The impact, what this does, is it's really like a war zone out there from an RF perspective. You can't see it without the right tools, like this, but it really is a war zone in 2.4. And there is space in the 5 gig available still, as you can kind of see. There are some areas here that are red that are just in a noisy state. So, but you can see 30 networks you can't connect. Well, that's all of those are generating noise and taking up talk time. So.
All right, so now's the time where I'm going to make you do some more exercises again. I want to get a quick poll around the room. So who here is using iOS devices? Certainly. Okay. Oops. Sorry. All right. Who here is using Android OS devices? Okay. Okay. Windows? Brave souls to raise your hands in this room. Mac devices? Okay. And Linux? All right, so the rest of you either are asleep or not listening, but you'd be considered in the other bucket as well when you're looking at usage statistics. So what I did was I took a breakdown of just traffic sampling that we have from one of our in-browser notification systems to see what's on the network. So it's relatively close to the same now, actually. And then out here during break, I also looked to see what the airwave system said, and that was kind of interesting because, as we said, there's different verticals and there's different ideas, right? So here there was almost 60% that was just Mac laptops and Apple devices, right? And then there was 14% that was Intel corporate, 9.6 of other, 4.8 of unknown. That's really helpful to try to figure out what's going on here. Another 2% of Apple, another 1.4% of Apple. So, that's all kind of aggregated together. I certainly know that Apple is quite the winner of choice here, but one of the things that that I think is meant to note is that when we understand what's on our network and we understand what that usage pattern is like, that really helps us for planning, right? So how else would we plan this room? I mean, certainly when all this room leaves, there's going to be tons of noise and interference because there's not a lot of bodies that are absorbing the RF, and there's, and now it's overkill, right? So how do you basically design for that bursty accountability that you basically have on any typical Wi-Fi network that's out there? How do you justify that infrastructure when the place sits empty 80% of the time, but when if this room fills up with however many people, that you basically need that infrastructure to accommodate and needs to be a good experience. So these are some of the things that are interesting for planning, configuration, and support.
In addition to that, no two clients are really the same. The battery life is a major factor on the smartphones, and as a result, the radios aren't as powerful when they transmit back to the access point. When you look at the FCC filings, they have a negative gain on their antennas typically, so the power output is between 13 and 18 dB. Tablets are a lot stronger than that. Your iPad, your Samsung tabs, your Note tabs, and 13 to 23 dB. Versus laptops, which are 20 to 26 dB of power output. The laptops are on par with what an access point puts out, but the smartphones are not. And the use case for Wi-Fi has changed over the last, 5 years, to where smartphones are now the target, no longer laptops. So you have to account for that as well. And the way the people are using the network is changing as well.
So I think we'd be remiss if we basically didn't say anything about mobility, since this is Wi-Fi, that is. So a known active MAC address is something that appears on one tunnel endpoint to another tunnel endpoint. That's what I'm going to define a mobility case in. And I think anytime when I look at any of the wireless access gateways, I see anywhere from 40 to 60% of those overall sessions to be defined as a mobility event. That's pretty large. It's astounding, actually. In fact, when we had these conversations about it, it was just, is that really right? Let's take a couple, no, just take a snapshot, take a poll, and we did a lot of data analysis. We're like, yeah, that's right. So some of the two cases that I want to point out that I think are the most interesting when we're talking about mobility and support are the first one where you basically have one client that sits in between two APs when you have similar RSSI values between the two of them, and you ping pong back and forth between them. And the other one is when you are walking down the street and you're bumping from AP to AP, or I don't know, I took the train down here from Philadelphia, so when I was on Amtrak, I basically bumped from AP to AP, right? That user experience was not good. I'm just gonna, I'm not sure who else is using it that often, but it really wasn't good. It kept jumping out, spotty in coverages, and it was mostly unusable. So one of the things that I think that if we're going to ever get to something that's carrier grade, the marketing term that is, I think one of the things that we need to think about is how we are going to do these secure fast handoffs, how we're going to do them in a carrier grade network where everybody has different APs, they have different infrastructure. We can't even play together in Times Square or in this building or anything like that. How would we be able to make that work, right? So, think back to the mid-2000s when secure SSID, meaning H01X authentication, started becoming prevalent in wireless networks, right? So you had the overhead of key caching, or you had the overhead of the four-way handshake, and then people are like, okay, we should do some key caching. That's fine on one AP, but now when we're roaming from AP to AP, this seemed as a problem. So vendors started couldn't wait for the H11R fast transition standard, and we started doing pre-authentication and opportunistic key caching, which all still exists now, which could solve a very real problem. But how do I do this between different carriers? How do I do this between all our infrastructure? We can define that. So I really do think that there's, I think we're in the birth of trying to come up with some type of new standard for this at this point in time, because it's the only way where I think it's going to work, and it's going to work reliably. So this is something for you to think about, and I'd love to, start up a chat with any of you here about some of that, because I think this is a problem that we've identified that we really need to work towards solving here. That's my shameless plug, sorry.
And it also has to be easy to use. I kind of use the rule of 6. Can my 6-year-old use it? Can my 60-year-old grandmother use it? And can I use it after 6 beers? And if it fails any of those, it's too complex to use. And that's what we've got. Are there any questions?
Questions? I guess the only
Okay, my
thing,
Twitter handle's awesome. I get it.
It's the only question I have is, can my 93-year-old grandmother use it after 6 beers?
Haven't met her, not
Yeah.
sure, but probably.
We do have a question, one question.
Hi, Chris Woodfield with Twitter. Is this the same technology that is driving the Xfinity Wi-Fi service that's piggybacking on consumer routers that Comcast is deploying?
I'll answer this. Yeah, so this is, most of the deployments that we were talking about were the outdoor, the venues, things like that. But yes, the same Xfinity Wi-Fi service that you would get on the outdoor APs or the small, medium business ones would be the same ones that you can opt out with in your home hotspot at home, yes. Or you can basically own your own equipment and not have to opt out.
Okay, thank you.
Okay, well, thanks a lot, Colleen and Daryl. That was actually really cool. No, okay, yeah. Okay, so we're up for break now. Our break is sponsored by, and I need to get glasses here. Our break is sponsored by Integra Optics, Myriad Supply, and our good friends at XKL. And if you're really nice, then they'll tell you what XKL means. So enjoy the break. Let's come back not too late, maybe about 5 minutes. You know, kind of get settled in at the top of the hour, and then we might start a couple minutes late because we're getting started late. So try to come in soon. Thanks.